Okay, so today we are going to review how to design a basic lattice for bioprinting on your BioBot using the software SolidWorks. This general approach can be used with any CAD software that can export an STL file. First, select to create a new part, then click on Sketch and select your plane. Select the Rectangle tool and create a rectangle. We also want to check our units. I'm going to create this design in millimeters. Now, select a side of the rectangle and create a 5 millimeter length. Then, create a 0.2 millimeter width. Zoom in, press Shift, and select the center of the rectangle, as well as the center of the plane. Then select that they be horizontal. To move the rectangle close to the center, select Move Entities and move the desired amount. Now we can zoom in further. Select the rectangle, then select Linear Sketch Pattern. Create 6 lines with about 1 millimeter spacing. We will adjust the spacing after to make sure that we have a square shape. To make sure the lattice is a square shape, we will use the Smart Dimension tool. Select the end of the first line and the end of the last line, then change the distance to 5 millimeters. Use the Smart Dimension tool again to make sure the width of the lines are at 0.2 millimeters and to make sure the length of the lines are at 5 millimeters. Now we want to connect these lines. To do so, create a rectangle at any point on the plane. Set the width of the rectangle to 0.2 millimeters using the Smart Dimension tool. Press the Shift key. Select the end line of the shorter rectangle and the end line of the first long rectangle. Make these collinear. Then select the top of the short rectangle and the top of the first long rectangle and also make those collinear. Next, select the end of the short rectangle and the end of the second long rectangle and make those collinear. Now select that smaller rectangle and linear sketch pattern to create 3 smaller lines. We can estimate about a 2 millimeter spacing. Align these shorter rectangles by pressing Shift and selecting the edge of the second short rectangle and the edge of the third line of the third long rectangle, and make them collinear. The third rectangle will then snap into place. Next, we want to create the bottom 2 connecting rectangles by repeating this process. As you can see, this will create one connecting path that will create our first layer of lattice. This design forces the slicer to follow this pathway. So now that we have our design, exit the sketch, then select Extrude Base. Extrude by the same amount that the width of the lines are, so 0.2 millimeters in this case. Then select the contours to extrude. You want to be sure to select either all regions or all contours when completing this step, or you will receive an error. Now you have completed the design of your first layer. Save the design as a solid part. Next, click Make Assembly from Part. We'll create 4 layers for this example. So insert 4 layers of the design you just created. Select the short bottom edge of one lattice and mate it with the longer edge of another lattice to create overlapping layers. It is also useful to mate a few other edges of the two lattices to make sure they are aligned. Repeat this process with each layer. Once you have finished mating each layer, check that everything is uniform. If not, you may need to add extra mates. Finally, save the file as an assembly and as an STL. The STL format is what we will import into Slicer to prepare for printing. Okay, so we just reviewed how to design your lattice file, but what are some lattice designs to avoid for bioprinting? Here is one example. Here, you can see this design combines the first two layers from the last video in one layer, creating a checkerboard. This may seem like a straightforward method for creating your lattice design, but we will see in Slicer that this design does not lead to an optimal toolpath. This design does not require an assembly, but will not give you an optimal bioprinting result. We'll save it as an STL to use as an example. Okay, so here is one more example of a lattice design to avoid. In this design, an outside border is created with two larger rectangles instead of the smaller rectangles shown in the first video. This design will lead to less optimal toolpaths. We'll save this file as well and create an assembly so we can show you the issues this design causes in Slicer. Okay, so now let's import these designs into Slicer. The center design is the correctly designed lattice, while the outer two designs are examples of what not to do when designing a lattice for bioprinting. Let's open the Slicer configuration. We will set a path height of 0.2 millimeters, the same width as our lines and layers, with fill patterns of rectilinear and line, with a 99% infill. We want to make sure all of our speeds are consistent, which we will set to 2 millimeters per second for this example. Then, under printer settings, we want to make sure our extruders are also set at 0.2 millimeters. Save these settings, then select them to slice our files. Using the preview options in G-code, we can highlight the toolpath for each of these designs. While each design may look okay at first glance, the toolpaths demonstrate why the middle design will create the best output. This design forces Slicer to create the fastest, most consistent toolpath, which will yield the best results for bioprinting. If you still have more questions about this process or anything else, please check out buildwithlife.com for more information.